So in this video we discuss about the classification of elements. That is the classification of elements in which type of, as we know in the previous video, there are three types. One is conductors, another one is insulator, and another one is semiconductor. Now first we discuss about the metal or conductors. Now as you know, this is the energy band diagram or EB diagram of conductors or metal. As we know that in this diagram you can see that the conduction band and valence band are no gap, and here they are overlapping each other. That means if the temperature is increasing, the overlap region is also increasing, and at the 0 Kelvin the both are in same line. That is conduction band and valence band are in same line, touch each other. So now as you see in the diagram, obviously the electrons and holes are transmitted to valence band to conduction band, conduction band to valence band. So they are good in conductivity. So the first point of metal is what? Very good conductors of current. That is current is good conductor. That is conductivity is very large. So very good conductors of current. Or we can say that conductivity is high. Conductivity is large or high. Now the second point is what? The energy gap, that is EG, energy gap at 0 Kelvin equals to 0. That is no gap between conduction band and valence band, and non-zero energy gap. And as we know the temperature is high, the overlap region, OL region is also increasing. That is two bands are overlapping each other. So this is another point. Now positive temperature coefficient, another point is noted here, that is PTC. This full form of, you write down, that is positive temperature coefficient, PTC of resistor. That is what is mean by PTC, that is positive temperature coefficient. That is if R will increasing with if temperature T is increasing, that is positively change. If T is increasing, then obviously corresponding R, that is resistance, will be increasing. Now another point is, this is unipolar. That is current is unipolar. That is what is mean by unipolar. The current is carried by only single type of charge carrier, that is only electron. That is only electron is the charge carrier. That is current is conducting only for the electrons. This is called unipolar. Another point is the formula. That is what is the conductivity formula of conductor. Conductivity of conductor we symbolize as like this, and equals to NQ to mu N, mho per centimeter. So this is the formula of conductivity. So this is the formula of the conductivity, where N is what? N is the concentration of electron, Q is the charge of the electron, that is 1.6 into 10 to the minus 19, and mu N is the mobility of electron. So now another point, or the next point is here, this is very important point, that is only drift current. Drift current, and we know that the two type of current, that is one is drift current and another one is diffusion current. But here for the metal or conductor, only drift current flows in the metal. That means in metal only drift current is flow. Now you can see the example, you know already, that is example of example of conductors or metal is like aluminum, copper, gold. These are the metal, and this is the high conductivity, we know that obviously, and silver. These are the examples. So here another important point is that the nature of bonding of metal is nature of bonding. It is sometimes very important, the points to remember, that is nature of bonding. What is the nature of bonding here? Metallic bonding. Nature of bonding here is metallic bonding. So up to this is the metal and conductors. Now the second one is semiconductor or insulator. We can discuss about the insulator first, then after that the new main topic is insulator. We have discussed later. So now insulator. So now let's talk about insulator. In insulator, this is the energy band diagram. As we know, the energy band diagram of insulator, this is the conduction band, this is the valence band, and this is the conduction band, this is valence band, and the gap between conduction band valence band, that is energy gap, Eg, is very high. How much? 5 electron volt for insulator. Now let's talk about the main points of insulator. This is not, main point is that is this is not conducting the current. So here the first point is that they are bad conductors. That is, the conductivity is very negligible. So first point is they are bad conductors. That is 0 for ideal. This is for ideal. In bracket you write that this is for ideal case, and for practical you write down that is sigma is very negligible. So as we know that there is similar to 0, that is for practical purpose, for ideal purpose. For practical is negligible. So this is for bad conductors. Insulators are very bad conductors of current. So they are not conducting the current. So second point is the energy gap. Obviously we know that in the diagram, in energy band diagram, the energy gap is very large. This is the second point. How much amount? Greater than 5 electron volt. Greater than 5 electron volt. Now the third point. So as we know that this is the third point about that, no electron can jump from valence band to conduction band. So no electron can jump in insulator. No electron can jump. So as we know that the gap is very high, so no electron can jump from valence band to conduction band. So what is the next point? That is, the next point is, this is NTC, that is negative temperature coefficient. In the conductor, what we are studied, that is PTC, that is positive temperature coefficient, but here there is negative temperature coefficient. That means what? If resistance will decrease with increasing of temperature. What is denote? Resistance will decreases with temperature if temperature will high. So this is called negative temperature coefficient. Now here, what is the nature of bonding? In metal, the nature of bonding is metallic, but in insulator, the nature of bonding, what? The nature of bonding is ionic. I-O-N-I-C, ionic bonding. So this is the nature of bonding for the insulator. And what are the example? As you know, example of insulator, that is air, we can say air, glass, wood. These are the example, or ceramic, plastic, These are the example of paper. We can also paper. These are the example of insulator. So now in the next we discuss about the semiconductor. That is the main part of the chapter or the main part of this whole subject. So the third part of the classification of element is semiconductor. The diagram of energy band diagram, as we already know, that is, this is the conduction band and this is the valence band. The energy gap between conduction band and valence band is less than 1.5 electron volt. It is less than 1.5 electron volt. Now here the first point is that the nature of the bonding. Here the nature of bonding is, what is the nature of bonding here? It is covalent bonding. Third one, second one is energy gap. Energy gap is less than 1.5 electron volt, and that is small. Energy gap is small. So, and third one is, there is a bipolar. Third one is bipolar. In the conductor, we know that that is unipolar. That is, current is flow for the only electron. Here, bipolar means what? The current is flow that is carried by both. The current is carried for both electrons and holes. So both are required to for flowing the current or carried the current. So this is the third point. Another point is, this is very temperature sensitive. That is temperature sensitive. Semiconductor is very temperature sensitive. As if increase the temperature, obviously the gap will be small and electrons can or holes can move from one conduction band and valence band to conduction band, and this is temperature sensitive. Temperature sensitive. And so energy gap is small. That is, if we apply some voltage or additional energy in terms of light or heat or electric field, the electrons can easily excited to jump from valence band to conduction band. So if this is very small, so if we apply, that is voltage, if we apply the voltage or a heat or a light or field can apply, then electrons can easily jump. So that's why this is called semiconductor. That is, conductor and insulator, between them is semiconductor. So now this is negative temperature coefficient, that is NTC. Which is NTC? R is decreases with increasing of temperature. Now energy gap. Another point is that energy gap is inversely proportional to temperature. That is, if temperature is increasing, the energy gap will decrease, and if the temperature is decreases, then energy gap will increase. This is for, as you know, in the metal there are for drift current, but here that is diffusion type of current. So the current is diffusion current flows. Diffusion current flows. An example of what? The example we know that there is silicon and germanium. This type of, we use the semiconductor mainly, that is silicon and germanium. So graphite metal semiconductor property. So here some important concept, that is why carbon is not considered as a semiconductor devices, or because also the carbon is present in the fourth group of the periodic table, as silicon and germanium. So but though carbon is not used as a semiconductor, because the main reason is that its energy gap is higher than 1.5 electron volt. As you know that the energy gap is less than 1.5 electron volt for semiconductor, but for carbon the energy gap is greater than 1.5 electron volt. And also the properties of the carbon properties of the carbon is unstable. That is, the properties of the carbon is unstable and highly unstable and unreliable and unpredictable. Highly unstable and unpredictable and unreliable. And carbon, so that's why the carbon is never considered as a semiconductor. So this is very important concept, as sometimes they ask. So this is the main reason behind this. So up to this video is ended. That is the classification of elements in detail. That is, our first one is the conductors, second one insulator, and now the semiconductor. And in the next video we discuss about the mobility of the charge carrier.